Welcome to our deep dive into the fascinating world of service accounts in Google Cloud. Today we're going to explore how to understand, use, and even impersonate these essential components of cloud security. This knowledge is crucial for anyone looking to master Google Cloud security. Let's start with the basics. When you begin your journey with Google Cloud, you typically start with user accounts. Think of this as creating your character in a video game. You, the user, are that character interacting with all the features Google Cloud has to offer. However, there's more to it than meets the eye. In this Google Cloud game, your user account is assigned specific roles. These roles are managed through the Identity and Access Management (IAM) system. This system is your key to controlling access and granting permissions to users. There are various ways to manage these user accounts. For instance, Google's Cloud Identity System works alongside features like Workspace Directory Sync. This allows you to synchronize with LDAP systems or Active Directory, giving you flexible options for user management. Now let's introduce a new concept, service accounts. These come into play when services, virtual machines, VMs, or serverless applications need to connect with Google Cloud. For example, when your application needs to link up with a database. Like user accounts, service accounts need to be assigned roles in the IAM system. These service accounts are created within IAM and gain their permissions to operate in Google Cloud through this identity. But here's where it gets even more interesting. Sometimes users or other service accounts need to impersonate a service account to complete a specific task. Let's paint a picture to help you understand this better. Imagine a VM that's been assigned permissions via a service account. When this VM needs to connect to something like a Cloud SQL Postgres database, it uses these permissions to establish the connection. The service account communicates with the Google Cloud Metadata Server to obtain a temporary token. This token acts like a secret key, allowing access to the database. Now that we've covered the theory, let's put this into practice using the Google Cloud Console. We'll start by creating a new service account, then set up a VM to interact with cloud storage using this account. We'll also explore the intriguing concept of service account impersonation and delve into the role of the metadata server. First, we'll navigate to the Service Accounts page in the Google Cloud Console. We're starting with a fresh project, so there are no existing service accounts. We'll create our first one and call it the Storage Viewer Service Account. This account will be our intermediary for interacting with cloud storage. We'll assign it the role of Viewer, which sets up its basic permissions. Next, we'll create a regional bucket for testing. We don't need to assign additional permissions at this stage because we're managing them at the project level rather than the bucket level. To make our test more realistic, we'll add a sample file to our bucket, let's say a screenshot. Now comes the exciting part, creating a virtual machine, VM, that will use our new service account to access the storage bucket. While we're focusing on Compute Engine for this example, remember that the concepts we're exploring, especially about the metadata server, apply across various Google Cloud services. Before we can create our VM, we need to activate the Compute Engine API. Once that's done, we'll set up the VM to use our Storage Viewer service account. We'll keep most of the default settings, but we'll make sure to grant full access to all APIs, including the Cloud Storage API. With these settings in place, we can create our instance. After the VM is ready, we'll connect to it using SSH, Secure Shell, through the browser. It's worth noting that we're keeping our resources in the same region. This isn't strictly necessary for our demonstration of roles and permissions, but it's a good practice for network efficiency. Now that we're connected to our VM, let's explore how it interacts with the metadata server. The metadata server is a crucial component that provides essential information about our VM. We'll use a command called curl to interact with it. The specific endpoint we're interested in is metadata Google internal. When we send a request to this endpoint specifying that we're using the default account for this VM, we receive a token. This token is what allows our VM's service account to authenticate with other Google Cloud services. Let's break down what's happening here. First, our VM, using its assigned service account, reaches out to the metadata server. Next, the metadata server provides a bearer token. Finally, this bearer token can then be used to authenticate the service account when it needs to access other services, like our storage bucket. To see this in action, we can use a command like gcloud storage objects list to view the contents of our bucket. Behind the scenes, this command is using a token similar to the one we just obtained to authenticate and access the storage. We can even replicate this process manually by using the bearer token in a direct API call to the storage service. It's important to note that these tokens have an expiration date for security reasons. When we do this, we receive a JSON object listing all the objects in our bucket, including the screenshot we added earlier. In real-world applications, like when you're developing a Python application using the Google Cloud SDK, the process of obtaining and using these tokens is handled automatically. The SDK takes care of getting fresh tokens and managing authentication within the framework of the service account we set up on the VM. This demonstration shows the power of the metadata server and how it facilitates secure communication between different Google Cloud services. In essence, we've pulled back the curtain on what happens when you run a simple storage list command. Now, let's dive into the fascinating world of service account impersonation. This is where our journey takes an exciting turn as we explore how one account can temporarily assume the identity of another within Google Cloud. Service account impersonation is a process where a user or another service account communicates with Google Cloud resources by temporarily taking on the identity of a different service account. This can be incredibly useful in scenarios where you need to perform specific tasks that require permissions you don't normally have. To demonstrate this concept, we'll need to create another service account, this time with BigQuery permissions. Let's call it our BigQuery viewer and give it data viewer permissions at the project level. Before we proceed, it's important to note that, like Compute Engine, BigQuery is not enabled by default in your Google Cloud project. So we'll need to activate it first. Once BigQuery is enabled, let's create a dataset. For our demonstration, we'll leave it empty. Our goal here is simply to list datasets as a test of our impersonation setup. Now let's return to our VM and use the BigQuery command line interface, BQ-CLI. This is essentially a specialized version of the Google Cloud CLI focused specifically on BigQuery operations. Remember when we mentioned that the Google Cloud CLI has a flag for service account impersonation? Well, we're about to use it. But instead of using it as a one-time flag, we're going to set it up more permanently using a special command. Here's what we'll do. First, we'll grab the ID of our BigQuery viewer service account from the Service Accounts page. Then we'll use a command to set up our VM to impersonate this BigQuery service account. It's worth noting that if we ever want to stop this impersonation and return to using our VM's default service account, we can simply unset this configuration. Now here's where things get interesting. At this point, our original service account, the storage viewer, doesn't actually have permission to impersonate the BigQuery viewer account. We need to set up this bridge to allow the impersonation to take place. To do this, we'll navigate to the BigQuery viewer service account in the Google Cloud Console. In the Permissions section, we'll grant our storage viewer account the ability to impersonate the BigQuery viewer. We don't need to grant sophisticated permissions here, we just want to allow the impersonation and token generation. With this bridge in place, let's visualize what's happening. We have our VM, which is using the storage viewer service account. We've set up this account to impersonate the BigQuery viewer account. So, when we run BigQuery commands, we'll effectively be operating as the BigQuery viewer. Now, let's put this to the test. We'll try to list our BigQuery datasets using the BQ CLI. If we encounter an error message at this point, don't worry. It's likely telling us that we need to enable a specific GCP service for this impersonation. This is actually a good sign. It means we're successfully authenticating as our storage viewer and attempting to impersonate the BigQuery viewer. Once we've enabled the necessary service, we can run our command again. If everything is set up correctly, we should see our demonstration BigQuery dataset listed. This complex dance of permissions and identities might seem overwhelming at first, but it's a powerful tool in the Google Cloud ecosystem. It allows for fine-grained control over who can do what, while also providing flexibility for tasks that require temporary elevated permissions. Check out the video description for the diagram file from today's demonstration, and we'll keep an eye on the comment section for any questions. If you'd like to support the channel, try a free trial of our new design tool linked in the description. Thanks so much for watching until the end, and please enjoy responsibly.